Well, good morning, dear, and I hope all of you are doing great. Today, we are going to take you to the tour of Bayesian Naïve-based classifier, and today we will discuss multinomial event model. So far, what we have discussed, Naïve-based has three algorithms of Naïve-based which we are going to introduce you with. Okay, out of three, GDA already is known to you. So all the three actually of Naïve-based algorithms differ only in the representation of the representation or assumption of the features, right? In GDA, we assume that the features are random continuous variables and they follow normal distribution. Okay, and if this assumption is true, means in reality your data is following this they are random continuous variable and following normal distribution. This is the best algorithm which will perform among all the Naïve-based algorithms, right? And it is too simple to implement, so you should go for it. Then the other day we discussed about the multivariate Bernoulli event model, where again the feature, if you see the features are like we have a dictionary kind of thing which we call vocabulary, okay, and features are Bernoulli, they are following Bernoulli distribution, and features are actually a vector. Say you have 20,000 vocabulary, so 20,000 cross one dimensional vector, and say this is my dictionary, absence, abacus, blah blah blah, and you have money, lottery, then zero. So this could be huge vocabulary, 10,000, 20,000, right? And this xi represent a single trending email where the words, say normally the emails are of few words than 20,000 words. So what it will do, and each word in the dictionary has a rank. For example, A has first rank, maybe these are all example I am giving. Money has the 300 rank, lottery has, so lottery should be above money, so 2050 rank, or whatever it is. Okay, each word has a actually has an index, not rank, sorry, it has an index. Okay, it's represented by index. So the feature is representing on the mail like this. If it finds a particular index word, in that particular position it will put 1. If it is not finding a word in that next index position, it will be 0. For example, if it is 1, this is first position, second position, third position. So this, if abacus word is not there, okay, it will put a 0. If it is there, it will put 1. Here it will put 1 in the respective place. So I think it is very clear, it is simple. So j equals to 1 when particular indexed word present, okay, word present, and equal to 0 when that particular the 0 of that position, when word is absent, right, in that particular position. In that way it tries to capture represent the feature. Now one basic problem with this is, while it is simple, basic problem is this, since the mail or Twitter message, they are of very few words nowadays, right? And nowadays people are too busy to write big mails, so 10, 15 words. But for that, this matrix will be very sparse, the vector will be very sparse kind of vector, means only few will be 1, all other will be 0, and you are representing, and it is consuming a big space, unnecessary space in the memory. So that's the problem with multivariate Bernoulli event model, but the advantage where they were following Bernoulli distribution 1 0 1 0 only. Okay, but disadvantage is this. So multinomial event model exactly try to just remove this disadvantage. Okay, so what it tries to do is the following. Okay, here the representation of the feature is different, and assumption is that the features follow multinomial distribution. Okay, and say that this is my vocabulary. Okay, of 20,000 word. So xj and email has, say for example, hello dear, how are you? So xj will now represent this mail by this vector, hello dear, how are you? So all these things. Okay. Whatever it will find in the mail, it will put them in the vector form. So how many words are there? 1, 2, 3, 4, 5. So 5 cross 1, that is n cross 1 n is the dimension, how many words are there. Okay, so this is as advantageous, isn't it? And of course this I have written it in a very simple way, but as you know, all the words has an index in the dictionary, so they will be of that value, say 400, 200, 450, 100, okay, 900, like that. Okay, so they are representing now. So the j equals to 1 to 5. And another problem was in earlier representation, that in when 1010 is there, so each is dedicated for a particular indexed word. So if the word is repeating a number of times in the mail, it could not capture in this representation. But that problem is gone in multinomial event model, because as many times a particular here, for example, hello, if it is appearing again here, hello, or dear, again appearing dear, so it will be repeated. Okay, and so that frequency of the word could be captured. Okay, so this is basic difference between these two and multinomial event model, which we are going to discuss today. Okay, with an example. Okay, say let us try to now develop, we have enough background knowledge, let us try to create a model, and from based on Naïve based multinomial event model, and then try to predict from training. So all these stages will be visible to you. So let us assume that we have taken word of five words. So my vocabulary is five word vocabulary, because you know that we will be doing by hand, so we'll have to be it has to be simple. So hello, dear, got, lottery, money, these are my words. Okay, first step is to make so first you decide the number of mails which you are trying to use for training. So 30 mails we have decided, out of which 20 mails will be normal message and 10 are spam mail. By the way, everybody knows what spam mail is, right? Which is apart from normal mail. Spam mail actually creates annoying mail, creating some messages which are sometimes not appropriate, and sometimes fraudulent message. For example, you have $1 million lottery, all kind of nonsense they will speak. Okay, so those are nowadays flooded in our and some kind of advertisement, which undesirable advertisement which you do not want. Though those spam mails every day you see in your folder, right, inbox folder, and we definitely do not want that. So our strategy is how to create a filter or classifier which will just see the spam, it is spam, and either it will reject or it will put it some other folder, spam folder, so that you will not see, and that mail is definitely not urgent. So that's the spam mail, and normal mail is of course. So I am trying to show you how to design a Naïve based classifier for designing spam filter. For that unit training example, so 30 messages, 20 are normal, 10 are spam mail. Okay, and we have created extremely simple vocabulary of 5 words, because just to do by hand, the illustrative example should be small, otherwise it will take a lot of space. So these are my xj, okay, j equal to 1, 2, 3, 4, 5, and these are my 2 classes. This is y equal to 0 class, and that means normal message, and there are 20 mails samples, and this is my spam mail, there are 10 samples. And say here I have computed the frequency of the word from the 20 mails. That means all the 20 mails were scanned, and it turns out that hello appeared in 20 mails 20 times, and dear appeared 15 times. These are the mere frequency. Got appeared twice, lottery appeared 1, money appeared 2 times, and that's make total word 40. Similarly, these are the frequencies of words in the spam category mail. Okay, and then we'll have to actually calculate that probability. So calculate the probability of saying each word if, say, it is normal message. Okay, so we'll have to calculate that, and how to calculate is very simple. Say what is the, so we have this, okay, so this is the basic one, hello 20 times out of 40 total words. So what will be the probability given 0? That means what will be the probability of hello provided it is normal message? That will be equals to 20 divided by 40 equal to 0.5. So likewise we can calculate. So you, together with your this time you need a notebook with your pen and paper. You please also help me and calculate yourself, so that it's very simple, so that if I make any mistake, okay. So normal I am representing by n to save space, equal to 0.375 probability that word so hello dear, and then what we have got, okay, thereafter lottery and money. Okay, 2 times it appeared, lottery given it is a normal mail only once. In your training sample it was only once, so this is a part of model building. Okay, you see we are trying to create model, that means pxj. So you remember given y, and we also need these two things. So that is what we are trying to build. Okay. Now say when, so this is the probabilities, okay, and let us try to write it down, all the probabilities. That will be useful. 0.5, 0.375, 0.05, 0.05, 0.025, 0.05. These are the probability. We have written it explicitly here. Now think about that when you have when j equals to 1 to up to 10,000. Then what will happen? How to write that? And suppose you are interested to develop the algorithm of your own. So you need to go for maximum likelihood estimate, and we have already discussed, you need to directly compute it from the parameter. I equals to 1 to m. What is m here? 20. So we will be using indicator function concept. J equals to 1 to n equals to here 5. Then this is the indicator function xj and y I equal to equals to 1 to n y I equal to 0 times ni, where ni is the number of words in the ith term mail or sample. Is it clear? So this is very interesting. We have already reduced, and this notation Andrew has developed in that has talked about it in Coursera. So I am trying to introduce this same notation so that you can feel comfortable when some of you may visit, read his Coursera materials, and they are extremely simple. So I don't think we need to explain, but still I will explain those who are yet to understand and those who are interested to develop the not to use function, develop the algorithm of their own, and that's what you will have to do, and it is expected from you. You see, we have two for loop here. Okay, so what is our interest? Our interest to create this table. This is, nobody is going to give you 20, 15 manually, you are not going to get it, right? So algorithm will give you, input is the email, okay? So when I equals to 1, for example, then ith mail, right? First email is given to you, and then you are trying to figure out what are the words there, okay? So this is, you got one word, put one, okay, and the word should be in the class of normal mail, okay, non-spam. This is the AND operator is telling that out of all the words, the words only you will take which belongs to normal class, okay, and then you are counting the words and you are putting that many 1 are there. Okay, so dear, for example, 5 times you have scanned, so my vocabulary was 5. Okay, so and you could say, for example, in mail number 1, you could figure out only 1 or 2 D. So there will be 2, and then like this, you will have to complete all the 20 messages, and then 1, 2, 3, 4, or whatever count, and then you will end up with 20. Okay, after running this loop. Okay. And then you divide it by number of words in the ith training mail. So that particular number of words in the ith training mail, that is what, and how many total words are there, that is what it is telling you across all the mails. You see, total 40. So in an automated way, this formula is helping you. This is indicator function. Okay. Okay. So I will not tell you again and again. This indicator function concept has been clearly understood and discussed earlier also. We will use it. You will use it because you will have to develop the algorithm from the scratch. That is what I want. So good enough. So what we have done in the normal mail, we have calculated all the probability of seeing each word if it is in the normal message. Okay. We will repeat the same thing in say step 3. We will repeat the same thing provided it is in the spam message. Okay. So calculate the probability. Calculate the probability of seeing each word in a spam mail, right? As earlier, we will have to do probability of word 1 provided. Now you have 1 equals to probability of hello, given it is spam, also how many times, let's go back here. 5 times hello occurred out of 20. So 5 divided by 20 equals to 0.5. So please do with me so that if I make any mistake, you can correct me. Dear sorry, why we are writing, putting bracket here. This number we will have to put directly. So 5 by 20 2 by 20 equals to 0.1. Zero, because there was very interesting. There was no word in spam mail. Lottery, giving it spam. 8 by 8 times, you see. All spam mail make all of us very rich virtually, because we win lottery, millions of dollars every now and then in spam mail, right? So you see, you have collected correct data, samples 0.25, and in generalized form, again using indicator function notation in generalized form. We can use y equals to 1 equals to equals to 1 to n, and j equals to 1 to n. There are for loops, okay, and exactly similar what you will have to write. Okay. X k times equal to 1, and I equals to 1 to m. Here m is I think 10, right? N is 10, and n is of course 5. So indicator function yi n is again number of words, as is the number of words in the ith training mail or message. So directly we, actually what I am doing by hand 2 by 20 is that 20 even can be, so all the data is filled up with this if you write the algorithm. Okay, so input will be your mail, words with index, vocabulary, okay, and automatically you will be able to calculate probabilities of seeing each word. So far so good. So we have probabilities, and then we will calculate prior probabilities of also, okay, classifier probabilities, because you know if you do not know what is the classifier probability, you can assume any value. Okay, so what is the probability, right? Here in case of normal mail, you have 20 normal mail, right? 20 normal mail out of total 30 mail. So class prior will be 0.67. Class prior for spam class, it will be 0.33. So that is actually 1 minus of this. So these are called class prior. You can logically compute them from the data, or if you do not know in a situation, it can be just taken as 0.5, but definitely when you add your knowledge or ground truth, they will be better, giving better result. Okay, computation will be shorter. So these are called class prior, and you know that in terms of indicator function, again we can just have this equals to I equals to 1 to m. M is here 30, total 30 mails are there, and then indicator function divided by m. That is all we did, right? So indicator, how many? So indicator function actually it's telling you the frequency. Okay, how many times that mail is there? So 1, 1, 1, 1. So when it is normal, so there are 20 times. So 20 divided by total 30. So you will calculate this, and for this also accordingly you need not calculate it, because once you got it, 1 minus that will be the class prior for the other class, because I have 2 class only here. But if you have multiple classes, it is good to know that how to calculate class prior. Okay, so far so good. I think you are with me. So we have calculated. So we have built the model. What we have built? We have now everything, right? All the probabilities of xj given yi, okay, and we have classifier probability. So now we will use this model to predict. So in the next class, we will start from here. Please bring back your pen and paper so that we can work together. With this, thank you very much for your attention and stay safe. All the best.